Hello guys, welcome to Michsurd Academy. So we continue from our last class. We are going to be discussing on dimension in physics today. So my name is Akalo Ifeanyi Michael. So in case you are new to the channel, you have not subscribed, I would like you to click on the subscription button. It does not cost you any money. It's totally free. Okay, so as to get updated with our series of videos that will be coming up in physics, maths, chemistry, and so on. Alright, so today when we talk about dimension in physics, okay, we have this MLT that comes to our mind. Okay, so these are capital letters M, L, and what, and T. So we are M here. I'll write in this place signifies mass, then L here signifies length, and T here signifies time. Okay, so when you see M, capital M, we are talking about dimension for mass. We look at capital L, we are talking about dimension for length. And when you look about as in capital T, we are talking about dimension for time. All right, so now let's use this example. We are asked to find the dimension for area. Okay, let's start simple. So area is the same as length times what? Length, which is the dimension for length is what? Is capital L. So we write what? L. Then this other length we have under L. So this will give us L what? Square. So that means the dimension for area is what? Is L square. Alright, let's do for volume. Volume is length times length times length. Okay, if you are looking at a cube, so that this will be L times L times L, which will give us L raised to power what? 3. So that is the dimension for what? For volume, L raised to power what? 3. Alright, so we have for density as a quantity. Density is given as mass all over what? Volume. Then our mass is dimension as capital M. Okay, mass is dimension as capital M all over. Our volume, we have gotten the dimension as L raised to power what? 3. Alright, so from our indices, we can write this as capital M L raised to power minus what? 3. So this gives us the dimension for what? For density. Alright, let's take another example. We have for velocity. Velocity is given as displacement all over what? The time taken. Alright, so our displacement is dimension as it has the same dimension as length. Okay, so it will be capital what? L. Then our time is dimension as T, so it's capital what? T. So that we have this to be from our indices, this will be L T raised to power what? Minus 1. That means we have bring this our T upward, it becomes what? This. Alright, so we have acceleration as another example. Acceleration is change in velocity with respect to what? Time. So that this will be the dimension for velocity is calculated as Lt minus 1 all over. Then dimension for time is what? Is T. Alright, so that this will be equal to, now this is what we are going to do. We are going to write our capital L here. Then we have T. This other T here, we move up here. It will become T raised to power minus 1. So from our indices, it will give us minus what? 2. Alright, so this becomes the what? The dimension for what? For acceleration. Alright, let's take for force as another example. Force is mass times what? Acceleration. Then mass is dimension as capital M. Okay, then our acceleration, we have gotten it as L T raised to power what? Minus 2. So the whole of this gives us the dimension for what? For force. Okay, so let's take more examples. All right, another example we have is pressure. Pressure is force all over area, okay, which is equal to, our force is dimension as m l t minus 2 from what we calculated before. Then all over area is dimension as l square, right? All right, thank you. So this will be equal to, now look at this, I have l raised to power 1 here and I have l raised to power 2 here. All right, so that this can cancel one of these, so that what I will have is m, then this my l will come up so that it becomes l raised to power minus 1. Then I have my t minus what? 2. So this becomes the dimension for what? For pressure. All right, let's do another one. Work done. Work done is given as force times displacement or distance, okay? So that this will be, the force is dimension, from what we have that force is dimension as mlt minus 2. Then our displacement is dimension as length, that is l, okay? So that this will be equal to m, then l we times with l, we have l squared, then t minus what? Minus 2. So this becomes the dimension for what? For work done. Now energy has the same dimension as what? As work done, because energy is the capacity to do what? To do work, or the ability to do work. So it has the same dimension as what? As work done. Okay. So you can see in your exam, this such kind of question, which of these have the same dimension as work done? You see different options. The correct answer is what? Energy. Okay. So we have another example. Power. Power is given as work done all over time taken. Our work done is dimension, from what we have calculated, is ml squared t minus what? 2. That's for work done. Then time is dimension as well as t. Okay, so this is having a power 1, right? Positive power 1. Then this have, the one above have a negative 2 as the power. Okay, so you can't cancel out, just like we cancel out for these two. It is because the powers, they are positive and positive. Okay, so we are free to what? Cancel out. Are we together? All right. But yeah, this is negative and this is positive. So what you simply do is this. We have ml squared, ml squared. Then if I move this t upward, it makes the power to be negative, okay? So that we have t minus 2 minus 1. All right? So that this will be t raised to power minus what? 3. So this gives us the dimension for what? For power. All right, let's try another one. Velocity gradient. The velocity gradient, okay, is given as velocity all over length. All right, so that our velocity is dimension as l t minus 1. Then our length is dimension as what? L. So you can see that this l, we cancel out this l, they are positive, positive, right? Okay, so that what we have left is t raised to power what? Minus 1. So that gives you the dimension for velocity what? Gradient. So the question is, I want to ask a question. Which quantity have the same dimension as velocity gradient? So comment on the comment box there. Give me your answer. Which of them have, which quantity do you think have the same dimension as velocity gradient? All right, so we are going to end the class here for today. All right, so in our next class, I will give you some importance of dimension and how we can use them to also solve more problems. All right. So thank you very much. So if you have not yet subscribed, just click on the subscription button, and it does not cost you anything. So thank